And today we're going to look at processing data with Python inside Jupyter Notebooks. So we'll go ahead and get started. What we're going to do, we're going to talk about the actual steps that we're going to take in order to do some machine learning. Now, as you notice right here, the very last step is learn from data. So we need to get some data first. And we're going to do a tutorial where we look at some AirBnB data. If you're not familiar with AirBnB, it's a company that allows people to simply rent out their rooms or houses or properties that they own for short amounts of time. And it pretty much competes against the hotel industry. And Airbnb is kind of like real estate, where if it is in a very expensive part of the nation to live in, then the rentals are going to be high as well. So here's their website, and of course we see the COVID-19 thing there. And what you can do, you can just search for any particular place. So you could put Miami, Florida. Maybe you want to go in, I don't know, pick June for this many days. So it's very similar to the hotel industry. And you can see a bunch of places that you can stay. You can filter it, whatever. So I was able to get a bunch of data. I forget where I got it from, honestly, but I'll give you the file. And it has a bunch of Airbnb data for New York City. And New York City has the 5 boroughs, and usually it's going to be pretty expensive to stay there. Right? So we have to get some data, usually in CSV format or text format or something that we can process. All right. Now, you're going to find out that you need to sometimes format the data, scrub the data, just make it so you can process it. Sometimes it's in the wrong format. Sometimes there's errors in the data. It's missing fields. You just have to deal with that. And a lot of times this can be the step that takes a lot of the time. Then you can summarize it and visualize it. So before we even start throwing any machine learning algorithms at it, you just want to take a look at it and see what you have. You'll want to identify outliers to see if there's any kind of bad pieces of data in there. And then when you're done with that, you can learn. Now, you probably will have to maybe repeat these steps, right? Because once you learn, you might realize you don't have good data, and you might have to fix something and go through these steps again. Maybe you have outliers, right? So this process can be iterative, right? So acquiring data, what are we going to do? We're going to go ahead and grab some data, and it's going to look like this format. Don't worry about what it actually looks like now, but this is a CSV file with a bunch of data in it from Airbnb in the New York area. And you can see the field names are at the top, and we're going to look at latitude, longitude, minimum nights. Price is in here somewhere. I think it's just cut off. And then you might be required to format it, right? Things might be in the wrong format. They might be inconsistent. They might be missing fields. As you can see right here, we have some things missing, so forth, right? So we might have to format some things to get it in the right format there. All right, then you want to summarize data. So a lot of times we're just going to look at some basic statistical data. Count is how many items we have, and I'll show you that right here. So looking at count, this says how many items do we have in each of these. And luckily these are all the same, it looks like, for the most part. So we have 48,895 records, and these all here have good records. Now, it looks like some of them are missing reviews, and that's okay. Right? So No problem there. We can deal with that. They have, let's look at the other things. Mean, that's the average. Well, I don't know that we care about the average latitude and longitude right now. Doesn't really make sense. The average price is 150. Okay, so that's good to know. But let's look in the price column. So we have the standard deviation, and that's a measure of how closely all the points fall around the average. So a high standard deviation means that the data is not very similar. A tight standard deviation or a low standard deviation means they are very similar. Now look at this. Look at the price. We have a minimum price of 0. So again, that could be due to anything. Bad data, somebody put it in wrong by accident, but we know nobody's going to probably rent their place for free. So we'll have to deal with that. The maximum price, 10 grand, that's probably possible, right, per night in New York City. Okay, because they might have multi-million-dollar apartments. All right, now let's look at some of the other ones. How about this? Minimum number of nights, 20, that's okay, right? So I'm sorry, that's not right. Minimum number of nights is 1. Sorry about that. That seems reasonable. You have to stay at least one night. But this one, that one might be tough because 1,200 days is a lot of days. Right? That actually ends up to be something like 3 years. So again, what does that mean? Well, someone might be trying to cheat the system there. Oops, sorry about that. They might be trying to cheat the system and using this as a rental tool instead of an actual short-term, rental for rooms. I don't know how that goes with Airbnb's policies, but in any case, I would say this is not typically the norm. Okay? Usually it's a couple days or a week or two, maybe a month, I don't know. But not multiple years like this one. All right, now let's look at some other data. Number of reviews per month, right here. All right, now the low would be none. I don't know how you have a partial review or if this is just an average, whatever, but someone has 60 reviews per month. Now, I don't know if that makes sense, if this is per user or if this is per property that they are renting. If it's per property, this doesn't make any sense. How can you possibly have 58 reviews in a single month? You would need to have 2 reviews per day, and that doesn't make sense. All right, so let's look at the next ones here. It'll be over here, the latitude and longitude. So looking at this, we can see that the latitudes all look pretty good, right? We have them all right around 40, and the longitudes right around -73. And that makes sense because this data is New York City data, right? So that was controlled pretty well. Again, the standard deviation, very low, right? You can see this is very low, right? So very small standard deviations. You know that all these numbers are similar. So the next thing we want to do is probably just visualize some data and just look at data, right? So we'll make some graphs. I'll show you how to do that. And then we're going to want to find some outliers like what we talked about there. And then we're going to want to learn, right? And this chart this line plot doesn't make sense right now, but it will once we go through some of the tutorials. So what you're going to want to do next is go and log into your Azure Notebook. All right, so here I'm at my landing screen of the Azure Notebooks page, and I'm just going to go into my project, and I'm going to make a new project, which is the button right there. And let's call this Airbnb students, we'll say. And I'm not going to make this public for you, so you're going to have to do it yourself. All right, so one of the things you're going to have to do is actually get the file into the system, right? The raw data. And I'll show you how you can do that. So you'll want to go to my website for this class, and you'll notice that under courses there is a link for machine learning, right? So here was your game programming thing. Here's machine learning, and that should take you here. The information was actually obtained from this site called Kaggle, right? So there's a couple sites here that actually give a lot of good machine learning data for exploration, research, testing, whatever. So you can go to this Kaggle site, and this is where I obtained this from. So there's all kinds of cool stuff right here with the COVID-19, but I did this tutorial. I probably prepared it, I don't know, 5 months ago. So you can look for BNB or Airbnb. Try searching for Airbnb. Maybe there's a space. Let's see. Right, so Airbnb, all one word. Should find it okay. It's this one right here. This New York City Airbnb open data set. Right, so you can download this thing right here. So just click on the main link there, and then there's a download button right there. And this thing is going to want you to sign in. But what I'm going to do is post the data for you. So just go ahead and go back to my website, grab this file, Airbnb data, just download it. It'll download as a zip, and then you're going to want to uncompress it. So go ahead back to your Azure site here, and what you're going to want to do is just upload a file right here. And you can just go ahead and pick. I'll just drag the file in here. Here's my CSV file, right? And then go ahead and upload it. Once it's done, you'll actually have that file accessible inside your notebook. So right here, you can just go ahead and make a new notebook. All you have to do is do new and do notebook like you did for that one lab. I'm choosing Python 3.6 right here, and this is just the name of the notebook file, so you can call it Airbnb student, whatever. That's fine. And now we have a notebook file, and we have the actual data file there too. So you can go ahead and open that notebook. You'll probably end up getting a couple messages like preparing your computer or something like that. So we can just start by putting in just a hello world, whatever. We'll just call it Airbnb, right? And we'll just make sure this runs okay, right? And we're good. All right. So first things first, we need to import that data file, and we're going to use Pandas. So if you want to look more on what Pandas is, you can go to the website, but it is a standard tool for data analysis. It's very good for reading in data and being able to filter data, transform data, deal with missing data, commas, whatever. It's very, very good for reading in CSV files. So in Python, what you normally do is just kind of import things at the top, but I'm going to import them as I go along so they make more sense. And we can just abbreviate and use PD instead of typing out Pandas. So PD is kind of the standard name everybody uses for that as well. And what we want to do is just go ahead and read this thing in a simple line like that. So in Python, you don't actually declare variables, you just keep on using them as you need them. Just make sure that the actual file name that you uploaded is the same. Make sure there's not like a parenthesis 1 if you accidentally uploaded it or downloaded it twice, something like that. So going back into here, this is all we have. Just read it in, right? I can run that, and it runs fine. It's still running now. It has a star next to it. And then when it completes, you just see the number change over there. All right, so one thing we can do is we can print out all the data if we want to. It actually won't print everything if there's thousands of records. And so I'll show you what happens here. If I just say raw data and print it out and run this thing, you can see it tries to print out a good chunk of them, about 30 records, then it puts ... and remember we said there were about 48,000 records in there, right? So that's the part of the raw data there. So it's usually not a good idea to look at all the raw data just because there's usually so much of it. If you just want to look at a couple of the fields, just to look at the format, just to make sure things loaded right, you can do this. You can say raw data dot head, and it's a function like this. And instead of printing everything out, we'll just print the first 5 records, and that makes more sense there. You can see we have just an ID number, name, neighborhood. Look how they spell neighborhood with a O-U-R, lat long, rooms, price, minimum nights, etc. Now let's think of what we might want to do with this data eventually. Maybe we want to predict prices based on some of this data. Maybe we want to cluster it to see where the prices actually fall. Maybe we want to analyze it by location. So we'll get to some of the things we can do with it. So some other things we might want to do is try to see some of the categorical data. For example, neighborhood. We have Kensington, Midtown, Harlem, Clinton, Hill, East Harlem, right? And then we have the 5 boroughs right here, Brooklyn, Manhattan, and so forth. So we might want to just find out how many of these are there. How many neighborhood groups are there? We know there should be 5. How many actual neighborhoods are there? And then we can print out the number of listings in each. So the neighborhood group has the 5 boroughs. So what you can do, you can just do a value count right here and then just run that. And we can see that there are 1, 2, 3, 4, 5 of these, right? And there's 21,000 listings in Manhattan, 20,000 in Brooklyn, and so forth, right? So most of them are Manhattan and Brooklyn. And then these actual, let's see, these neighborhoods, you can do that as well. And you can see most of them are going to be in this Williamsburg. And then you can just see how many there are there. So it's a good idea to do this just to see what the categories are. So, for example, if we knew nothing about New York City and we didn't know there's 5 boroughs, we wouldn't know how many different ones are in here, right? Neighborhoods, I would not have guessed that there's this many neighborhoods. So room types, again, we have no idea right now how many room types there are unless we're very familiar with AirBnB. So what I'll do, I'll just print those things out as well. And we only have, as you can see here, 3 room types. And you'll remember from my slides, I showed some data about, some statistics about all of the data that we read in. And in Python, you can pretty much do that in one line of code. So I just say raw data dot describe. And normally this thing's at the top, but I'll just go ahead and do that. Oops, I missed it. I had this one highlighted. So make sure you highlight the one you want to run. So a little hint here, one of the things you can do is look at the shortcut keys, right? So you can see all the keyboard shortcuts depending on what system you're on, Mac or PC. And then you can also look at the editing your shortcut keys. So if you want to make a custom one, you can do that. So I'm going to just use a shortcut key. Normally this scrolls up and down, but when I zoom in to make the font bigger, it doesn't keep that header at the top. So I'm just going to go ahead and run this, just Shift Enter. And this is how we can do this in one line of code. Just get all these statistics about all the fields. Another thing you can do is just get a lot of plots printed for you that are going to go ahead and show you very useful things like histograms. So a histogram just shows you a count versus a category. And we're going to use matplotlib. And again, that is a standard tool that people in Python use. So you do have to put this one line of code in here, matplotlib inline. All right, and then you're also going to have to import it, and pretty much everybody always calls it PLT for plot. Okay, so you can run that. It's not going to do anything. It just says, okay, it's imported. That's all that's going to happen. That one usually takes a while to run. Now here's where we have to start trying to use some analysis. So what I'm going to do, I'm just going to print some histograms on all these pieces of raw data that we have. So I'm just going to put a histogram. Now I picked 50 bins, and how did I come up with that? I just came up with that, right? So the number of bins is going to be different really for each of these, but I'll just go ahead and run this thing here. And what you want to do is make a plot and show it like this. And what it does, it will go ahead and just plot all of these things for you. So we can look, and what this means is there's 50 bins. So there's a bin, there's a bin, there's a bin, there's a bin, right? There's 50 of these. Some of these don't even have 50, so it's okay there. So you can change the number of bins. You can just put 10 if you want to. Run this thing again. And this shows you the plot with 10 bins. These are just the figure sizes, how big each of these should display. Oops. Right, so you can adjust these as needed. This is just the X and the Y values. So I'll put that back the way it was, a little smaller. So this is just giving us an idea of what our data looks like. So let's take a look at each of these that would make sense. Well, let's look at the price. I mean, we would probably need a different number of bins here because they're pretty much all falling into this category, and the other ones are just simply not the other ones aren't visible because there's just so many in this one, 48,000 or whatever it is. And there's probably 1 or 2 up there. So in order to even see your data for this one, we'd have to just put some more bins in here. So I'll just change it to be 50 bins, and we'll just update this one right here. So I actually ran it again at 200 bins because it wasn't helping us. But we can see how many we have now. So we can see that most of these prices are in this range, and there's just a couple that are getting up here pretty high. Reviews, we can see the number of reviews and how many items are in each of those as well. So this is just telling us some information about the data. So what we want to do is find out where the outliers are. And another trick here, if you want to just put some markup in one of these cells, you can just put, actually it's marked down, sorry, not markup. You can put this in here, and you can just type anything you want right here, and it won't run it. It's just kind of like a comment, really. You just do that. It's just a comment, right? If you want to make headings, you can just change that to be a heading. And then you just use pound signs. The number of pound signs is going to determine the size of the heading. So you can say something like, let's find the outliers, right? And you can put that however you want it. And we'll just insert another cell. All right, so the first thing I would do is I would wonder why the minimum number of nights looks so funny. These kind of make sense, right? But look at this minimum number of nights. Why does that look so goofy? Probably because there's outliers in there. So if you want to query something and just kind of show it to the screen, you can just do this. Say, show me the raw data where the minimum number of nights is bigger than 180. I think a half a year is starting to get pretty unreasonable for, renting a room. So what we can do is just kind of run this and take a look and say, yep, we have several that are requiring a very high minimum number of nights. And that simply might not be what we're trying to look at, right? So there's 81 of those. So this didn't edit the data. This just displayed it to the screen. That was it. I can say, show me all of them bigger than 5. right? And then we're going to have lots of those, right? 10,000 of those, right? So I can say, show me more when you have to stay more than a year. Again, we have several of those. So what we can do is just kind of, we'll filter this thing out here in a second, but that just shows us some information. The next thing is concerning the number of reviews per month. So let's see how many of these have more than 30 reviews per month. So that means, let's see, we have only one. So apparently you can't really have more than 30 reviews per month. So this is probably just a piece of bad data. So if we want to actually save this, I'm just going to make a new variable called filtered data. At all times, I like to preserve my raw data and not edit that. I like to just make a copy of it with the filtered stuff in there. So I'm going to say filtered data is going to be raw data where the reviews are less than 35 per month. All right. And then I'm also going to put another filter in there. So let's see. Make sure you don't copy, paste, error this. You don't want to have raw data back there. Okay, you want to take this data and filter it again, and only take the ones where you have to stay 6 months or less. We might want to change this later. We might get many steps down and then realize that this number should be changed. So now we can maybe do some raw statistics again on this and take a look. All right, so let's see what we have now. Now we have 142. Number of reviews per month. 1.37 sounds more reasonable. And our max 27 still seems kind of high, but we can let that slide. Again, I'm still not sure if this is per user or per property. I don't know. If it's per property, then this thing can't possibly be correct. It's probably per user, right? So a user can have 100 properties if they want, and then it'd be pretty reasonable from that to get 27 reviews per month. We can print out the, we can display these histograms again with the filtered data now instead. And now they look pretty reasonable. Again, we really have this tight price range in here, right? So we would simply have to kind of zoom into this and see where the prices lay. So something we can also do, we have lat-long data, latitude and longitude data. And I don't know that it's going to be super useful for this, but you can print that out. I'm sorry, I keep saying print. You can plot that out pretty easily. All you'd have to do is just take your filter data there and do a scatter plot on it, right? Let X be the latitude, let Y be the longitude. S is size. That's the size of the point or every dot, and it looks something like this. And this actually makes sense looking at it. So this is a map of New York City right here. I can see that it's correct basically because of, it looks the same based on the map of New York City here, and I'll show you what I mean. So if I just bring this map over, it looks like this right here is Long Island, right, which is this part. Right, so this looks like Long Island, right? So a lot of rentals in that area. I believe this looks like New Jersey or whatever right here. Getting into Philadelphia, Manhattan would be somewhere in this area, in that dense area again. So the plot looks pretty reasonable, and it looks so far like the GPS or the lat long is accurate. You can adjust the size of the pixel here to kind of show how dense something is. So if I change this to 0.5 like I did here, and then change the alpha, which is how dark the pixel is, to maybe 0.1, it won't look like everything's the same color now. So things that are very sparse show as sparse. So we can see that, again, a lot of stuff on Long Island and then a lot of stuff close to the city of Manhattan, which makes sense. So we can actually perform some machine learning on this. One of the things we might want to do is just cluster the prices and take a look at what are our groups of prices, right? What price points do we have? What are our high price groups? What are our medium price groups? What are our low price groups? So if we were to plot them on a number line, we might want to see how many are around $100, how many are around $200. So what we're going to do, we're going to look at an algorithm called k-means clustering, and that is an unsupervised algorithm. And you might say, well, why are we using unsupervised? Because it's labeled data. Well, depends what we want the label to be, right? Maybe we want to figure out what our price is, right? Given a neighborhood, given a location, right? That's reasonable to try to predict a price.